Good morning. And myself, I am R. Joseph Paul, Assistant Professor, Department of Mathematics, SNS College of Engineering, Coimbatore. Today, our topic is about graph theory and its applications. So, already we have discussed about graph theory. So, graph is classified as V of E comma, that is G of V comma E comma psi of G. V it's called a set of vertices, E it's called as set of edges, pi of G it's a relationship between the vertices and edges. So in graph theory we were discussing about a simple and multiple graph. Simple graph is a graph which has no loops and parallel edges. When we talk about multiple graph which have loops and parallel edges. Similarly, we were discussing about a finite and infinite graph. When a graph G is said to be a finite, if it have finite number of vertices. A graph G is said to be infinite. If the graph is said to be infinite, then this graph G have infinite number of vertices. So next heading is we are talking about incident and adjacency. When a vertex U and V is connected by an edge E, that's meaning is E is equal to U comma V. E is connecting U and V. So we'll say that U and V are adjacent. Similarly, E is incident with U and V. So here this we are discussed about simple graph. Similarly, when we come for a non-simple graph, the same thing we discussed about it. So here we are talking about the applications. The applications of the graph theory, it's a vital role which plays in the mathematic modeling right now in the current scenario for all the networks, artificial intelligence, etc. So graph theory is a vital role which plays in it. So now let us have an applications in the electrical field. Some important definition. The electrical network A. A is an interconnection of a passive elements RLC. So we are saying a network is a interconnection of a passive elements. The elements we are taking it as RLC and the active elements as voltage source and current source. So with this we'll draw our network and we'll discuss about how it's going to be functioned. Node are taken as terminal common to two or more elements is called as nodes. So that is nodes we are saying the terminal common to two or more elements is called node. Branches we'll say is a link, that is meaning is edge. Link replacing the network element in a graph. Each branches join two different nodes. If a line is joined at the same node or a point, it's called as loop. So here we are saying it as a branch, a line replacing the network element in a graph. Each branches joins the two distinct nodes. Its meaning is the edge E, it's not a loop, and the edge will not have a parallel edges. So look at this. A graph, a collection of nodes and branches it means is edges, nodes its meaning is vertices. It shows a geometrical interconnection of the elements in a network. Direction, a graph whose branch are oriented, its meaning is a direction we have. So look at this, a b, it has a direction 2, its meaning is h. Undirected graph, a graph whose branches are undirected, its meaning is it don't have any directions. So this is an example of the electrical network. So we'll see with some other applications in the next class. Thank you.